Muted. Yeah. I don't think I've been muted this whole time. I don't think I've been muted all day. I have not. I muted it when we went on break. Yeah. That's why I don't like these breaks in the middle of class, because it's really thrown off my videos this semester, because I always want to mute and come back. Should I run through that again? No? Well, you tell me, what problem's on exam 1? Just in case someone watches this later. What problem's on exam 1? 4, 5, 9, 10, 13. That's it? Okay, that was exam 1. Exam 1. And then exam 2.
6, 7, 9.
10?
No?
Yeah.
Not one like that. 6, 7, 9? Okay. That's off exam 2. And then the new stuff, rational functions. One of those only the case where either the numerator is smaller than denominator or the same. And then simple interest, everything we did today. Yes.
Can we bring a sheet of the formula sheet?
Yep, same thing. You'll especially want a formula sheet for the rational functions, because you'll want to be thinking about like the different cases and all that. Anything else? So I'm going to send out exam 3 later today. All right? That will be due Wednesday. The quizzes from the rational functions, I'll give you the option. You can turn them in today, or if you want to have them so that when I send you exam 3, you have like something to look off of, you can keep them and just turn them in also with the exam. It's your call. I don't need them today. I'm not like begging for them. If they're more useful in your hands, then hold on to them. Y'all know what I'm talking about? The quiz that we did in class the other day? Okay. There were 2 problems, right? Yeah, so I would hold on to those. At this point, we still have a lot of time. If you feel comfortable, remember exam 3 is optional for you. The one that you do that I'm emailing is optional if you're happy with your 2 grades. Do I have an idea of, like, do you all have an idea yet, like whether or not you're going to do the exam 3?
Yes, I'm good.
Yeah. Okay, all right.
There's always that chance.
Yeah, okay. Now, it will not replace your final exam grade. It will only replace the first 2. That's it, all right? All right, so what I'm going to do now, you're free to go if you'd like to. If you don't and you want to stay, I'm going to do some rational functions. And depending on how many people stay, I may just put a couple of problems on the board and let you work through them and then kind of go over them afterward. And then after that, I really don't have anything else. So, yeah? Okay. At this point, whatever you want to do. Yes?
Is this 0.200 of a number? Not 200?
It's 2.0.
This one?
Uh-huh. Because you have to convert to a decimal. Yeah. 200% is twice the number, right? So you use 2. Yeah.
2.
Yeah.
2 times 4.
Yeah. So think about that. 200% of a number is 40. So that's saying like twice a number is 40, so the number should be 20.
Gotcha. And then this one I just
What is
0.32 times 92.
Yes, same thing as what we've had for the last exam. Did you just type it in, Ron?
I guess so.
Did you ever figure out how to do everything on the calculator? Yeah. I was gonna say, if not, I can give you
All right, no problem.
That's fine. I'm finishing this class on Wednesday, and in like 2 weeks I finish the other.
The other one? How's that other one going? Good.
93 on the first.
Oh, good. Good, good,
I
good.
saw it the other day whenever I
We just started getting into like
I was like, oh, I'll just do this the first.
complex zeros and complex this and that. But I've pretty much got a grasp of everything. I like it.
Good, good.
Are you gonna check our homework?
Your what?
Homework? Or like, you're good?
If your grade like comes down to a point where you're like really needing like a few points, like I might look at the homework as like, okay, you've done all this, great, you know? But it's not going to hurt you at this point, like if you haven't done something, yeah. All right, you too. So anyone who's interested in trying to graph a rational function that is similar to what I would ask you to do on the test, there it is. And then all right, there we go. Yes. Uh-huh. Mm-hmm.
This one, when considering the
Vertical
this right
asymptote?
thing.
Okay, vertical.
So
Mm-hmm.
this is where your x-intercept is, right? So this was there was -3 and 3. Oh, I'm sorry, it was 0 and 6. So I know that when I find this point, I can't go past this line. And considering my horizontal
Mm-hmm.
is this way, doesn't that mean that this is going to go this way, but then this can't go this way?
Okay, so the thing to remember about the horizontal asymptote, this one right here, is that when you draw it, do not draw it all the way across. Only draw it at the edges, okay? Because all it tells you is whether or not your graph is going to go towards it or away, towards the edges of the function. It has nothing to do with what's happening in here, which is why I said in class, don't draw it all the way across, because it's going to cause you confusion in here. As you can see, you did this side right, but this side should go like this.
This side
Should go up like that, yes.
and then this side should go up.
Should
like
go
this
up,
too.
yeah. But this should also come flatten out over here. Like, if that's your horizontal asymptote, then your graph needs to go towards that. So your graph would look like, here's that horizontal, here's that vertical, here's that x-axis, and you did a test point at 8, I think, right? And you got something here. So that means to the left, you have to go up. And notice, because I only draw this over here, it's okay for me to go up. And then to the right, it's got to flatten out towards that. Okay? So how do y'all want me to do this? Do you want me to just let you work these and then do the work on the board and have you look up at it? Or do you want me to, like, step by step right now go through it? What do you want to do?
Can you go through it? One, and then we'll do another one by ourselves. So if you go through this one.
This one, and then I can give you another one to do? Okay. So you want me to work through each of these?
Yeah.
Yes? Okay. Now, let me just see if I can't make sure I get all this on camera. Where is it? There it is. All right, so the one on the left there, this one requires quite a bit of work, right? What's the first step that you want to do for this? Let's just go around the room.
3x squared minus 2x equals
Okay, so what is it that we're doing? What is that step going to do for us? What is it getting us? X-intercepts. Okay, so we're starting out x-intercepts. Everyone good with that? To do that, you set the top equal to 0. Okay, I'm going to stay with you. That's what you want to do, right? Okay, so how are you going to tackle that equation? Yep, GCF. So what is your GCF that you pulled here?
I got 3x for outside.
Okay, 3x.
X minus 9 is equal to 0.
Perfect. Great. Good. Now? Okay. So the whole idea of factoring is to get these broken up so that you can set them equal to 0, right? So you're going to set each of those equal to 0. 3x gets set equal to 0, and the other one, x minus 9 equals 0. Now, can you tell me about this first one? What's the only number that I can multiply times 3 and still get 0? 0, right? So x is 0 is one answer. And then over here? 0. No. Solve for x. How can you get x by itself on that equation there? Not divide, because you have x minus 9, right? So if you have x minus 9 and you want to get x by itself, you need this 9 over here, right? So that means we'd have to add 9 to both sides. So x would be 9. And just think about it. 9 minus 9 would be 0, right? 9 minus 9 would be 0. So that should be our solution. So this is just one part of the problem. This is just our x-intercepts. These are just points that are on our x-axis. All right, what would be the next step? You know the next step? Set the bottom to 0. All right, and what is it that we're actually finding when we do that? Okay, the vertical ones, right? The vertical asymptotes, we set the bottom to 0. X squared minus 4 equals 0. So you comfortable with that? What do you got?
X minus 2 squared.
Okay, so you're going to do like difference of squares?
Yes.
Yeah. And then set them each equal to 0. You get 2, and then you also get negative 2. So I kind of skipped that step, but you'd set those both to 0, you get 2 answers. Difference of squares. All right, good. Who's got our third step? You want to do our third step?
Sure. Our third step is to find our horizontal asymptote.
Okay, how do we do that?
So we're going to use the leading coefficients considering that the powers are the same.
Exactly. So you first look at these powers and you see, are they the same, or is the top bigger than the bottom or bottom bigger than the top? I already told you that on the final, I am not going to make the top be bigger than the bottom, okay? So it's either these are going to be the same or the bottom's going to be bigger than the top. They're the same. So because they're the same, this is the time that you look at the coefficients, 3 and 1. This is the only time you do that, right? If these were different, you don't look at these. So it's 3 over 1, right? Yep, and I'm going to do something, I don't think I did this in class, or maybe I didn't stress it as much, but it's actually y equals 3. It's a horizontal dotted line, but remember we're only going to draw them at the edges. All right, so we've got the x-intercepts, vertical asymptote, horizontal asymptote. What was next? Do you have steps? Did you write steps down?
Points, yeah.
So test points?
Yeah.
Yep, okay, so we're going to do some sort of test points. Now to do my test points, I need to kind of start drawing a picture. I'm going to start drawing my picture over here. Now this is not going to be on camera, but I'll move the camera in a second. So here's my XY axes. All right, let me start putting some information down here. My x-intercepts are at 0 and at 9, right? 0 and at 9, and those are dots on the x-axis. 0, 9. There we go. So that takes care of this part. My vertical asymptotes are at 2 and negative 2. Those are vertical dotted lines. They go through x's 2 and negative 2. Not allowed to cross those. And then my horizontal asymptote is at y equals 3. And I'm not going to draw it all the way across. I'm just going to go to the edge. And when I say edge, I mean like past the last point I have information about. So here at 9, I know I have a dot. So I'm going to go past 9. I'm going to go out here and start drawing. And then I have to do that on the same thing over here. And I'm just going to, again, be at 3. And then really the last piece of information I have here is this vertical. So I'm just going to come out here and just draw it like that. Questions on that? You have some test points? You have test points? What are you using? Negative 3, that's a good one right here. What else? Negative 1's a good one. 1, good. 3? Or 2? Did you say 2 or 3? No, you said 3, right? And any more? 8? Okay, so 8 we could use. There's nothing wrong with using 8, but we actually don't need it. The reason we don't need it is because we have a vertical here, right? And we have an x-intercept here. We only needed 1 between the two. And I think you had said 3, right? So 8 would be another one between the two. It would just give us more information, but it's not necessary. We do need 1 more though, but not here. We need it on the other side. So maybe like 10 or 11? Yeah? So I circled all my test points. I also use little x's, not dots. And those test points get plugged into the function. Does anyone have any questions about where I got the test points, why I'm using those test points, why there's not more test points, why there's not less? Why we use test points, or why we're in this class at all. Any questions like that? No? Y'all are comfortable with that? Picking them? Now plugging them in, how many of you are actually just plugging them in and not doing that shortcut? Just plug them in? And there's nothing wrong with that. I mean, it just takes a little longer, but you get good values that way. The shortcut requires that you factor and you keep track of signs. It can be a little bit tedious also, but gets you there. I'm going to give you all a hint. I'm going to give you all a shortcut. Okay, I'm going to give you all a shortcut, but you may or may not like it. Hold on. Let's see. Do you remember on this function we factored the top already? Remember that step where we factored the top? So I could rewrite that as 3x and then x plus, minus 9, right? Now on the bottom we did difference of squares, so we knew that was x plus 2, x minus 2. Right? Now this is going to seem weird. I'm telling you it's a shortcut, but if you don't like it, you don't like it. Fine. Do you all remember with polynomials that idea of multiplicity, where it bounced or crossed? Remember that idea where you had you had to look at the power up on top, and if it was even, it bounced, and if it was odd, it crossed? Do you all remember that?
Yes.
Okay. Do you see that with all of these, the multiplicity is odd? It's ones on all of those? Okay. So if your multiplicities are all odd, then once you find your first test point, the rest just alternate. So if we do this first test point, -3, and we get it to be positive, our next test point will be negative, then positive, then negative, then positive. That's only if the multiplicities are odd, which is exactly what you should expect on the test. So what I'm telling you is, since you stayed here and you decided to take a little more time to do this, that on the test, please test all your points, but know that they will alternate. I'm telling you that they are going to alternate. You'll never have two of them do the same thing. Does that make sense? I think on the in-class quiz there was one of those where it didn't alternate. Like they were both on the same, they both tested the same way and they were right next to one another. So, all right. With that said, I'm going to go ahead and plot some points here. These are going to alternate. You're going to get positive, then you're going to get negative, then positive, then negative, then positive. And I should probably erase my x-intercepts that I had here that were black and make them blue just to reiterate that that's part of our graph. And now we draw. Who wants to come draw it? Go ahead. Very good, sir. Thank you for volunteering. So I'm going to help you think through it, but I'm going to kind of force you to consider things.
So that can't go above this, and it crosses through all the points.
Okay, so what I suggest you do is, start at the leftmost point, which is where you started. And imagine that you have to kind of like draw in two directions, to the left and to the right. Okay, so start by, at that point, to the left, what would have to happen?
So it have to go like this, and
Okay, you went too far. I wanted you to only consider one thing first. So like, at this point, just tell me what happens as I go to the left. It looks like, are you flattening out towards that dotted line?
Yeah.
Yes, okay, then I agree with that. That's what has to happen to the left. Now, before you draw it, tell me what has to happen to the right.
it has to go down because it can't go above this like dotted line, and it can't pass this.
What dotted line?
This going across here.
That dotted line doesn't go all the way across. And you know why I didn't do it all the way across? Because then you would think you can't cross it. Okay? It could go up there or down, but why not? One of those it can't do it. But why? This is where you have to. So try and draw it down. Don't actually draw it, but just think through. Like if you drew it down, that's right. And are you allowed to cross the x-axis there? What's that? No, right? Because the only places we were able to cross the x-axis ever are here and here, right? So if you do this, you created a new thing in the graph that doesn't belong there. So it's almost like a process of elimination. If you can't go down, you have to go up, right? So go ahead and just turn it up, and okay, that's good. Is everyone clear with that? Does that make a little more sense now? Okay, now at this point you have to jump to the next point and then try and play that same little game. Go out to the left and to the right. So tell me about out to the left first.
So it's going to go down,
Mm-hmm.
and only down,
Mm-hmm.
because it can't cross the...
Good, exactly. Okay, so to the right, what has to happen?
It can cross here.
Yep, it's got to get to that point. Yep. Yep. Okay, there you go. All right. Good. Now how about the next point? You have to go left and right out of that point.
So this goes down,
Mm-hmm.
and then it can cross.
Yep. There it is. Good. That works. Everyone good with that? Good, good. Okay. Should we move on to the next problem? All right. Let me just make sure I get that on the...
Real quick, when you
Yeah, yeah.
when you figure out that it's going to alternate and you have your horizontal and vertical asymptotes, you can just kind of put dots or points anywhere and just...
Wait, say it again. Once you find out where your vertical and horizontal and your x-intercepts are,
you can just put your
along with, yeah.
Yes, like how high they are and low they are.
Okay.
Yes, and that's where things can get a little tricky, is because some students might do something a little different. Like let's say you did -3 and you had a point here. Well, that's obviously not going to work. So like let's say you had a point here, and then maybe this point was here, and then this one was maybe here, and this one maybe you put that one there, and then this one, let's say you put here. So this person's graph is going to look more like this. It's going to flatten out. It's going to go up. Here it still has to go down, has to go through, go like that and go up. Over here it's got to go down, then over here, through, up, but then it has to flatten back out. So it's going to look a lot different than the other person's. Does that kind of make sense? Like the height of these points? But the general idea here is to figure out where the graph is above and below the x-axis. Kind of like with the polynomials that were like roller coasters. We didn't know how high they went and how low they went. We just knew like where they were above and below. So this is the same sort of thing. I know that this graph goes through at 9. I know to the right of 9, I'm above the x-axis. I also know from both of these pictures as I go out to the right, the graph goes to 3. So that tells me that with this function, if somebody gives me a huge number like 300, 400, 500, they ask me to plug that number in here, I can tell you with a lot of certainty it's going to be, the answer will be close to 3. Does that make sense? Okay.
So and on the end, your answer, you know how you do all the test points there?
Mm-hmm.
Doesn't really, is that going to be like part of the answer? You have to solve all that, or just put the dots there and draw the picture and you're good? You know what I mean? Because you have all your points down there, and if you were to plug them all in, are you going to want the answers to all of those?
Well, I'm telling you, this group here, that if you get the first one and figure out, let's say it's positive, then you just can draw me dots, negative, positive, negative, positive. You don't have to go through all these. Yeah. All right. Now, the next one, wait, what time do we end? 1:40, right?
140.
Wow, time's going by fast here. All right, let's see if we can't get this middle one taken care of. So the middle one, you invest $40,000 at 3.125%, and it's going to be there for 6 years, and we want to know how much will be there after it's computed these 3 different ways. So monthly, quarterly, continuously. So all you need for this is the formula, which you would put on your cheat sheet, right? Since I'm not going to provide that for you, you'll want to have those formulas ready to go. So for part A, I'm using the formula A equals P times 1 plus R over N to the N times T. A equals 40,000, 1 plus the interest rate converted to a decimal over the number of times compounded per year. Monthly is 12, and then 12 times 6. So I'm not quite sure what more I can tell you about that other than you're just plugging in. You need to be able to recognize what values are what. You know, like this is P, this is R, this is T. N comes from here, N is 12. That's part A. I'll get the answer out here in a second. For B, the only difference is same formula. 1 plus 0.03125 over quarterly. Quarterly is what? Four times a year. So N is 4 this time. And then that's going to be 4 times 6 up here. That's our exponent. And then for part C, we want to be able to do this continuously, which means we use the other formula. P e to the RT, which is 40,000 e to the 0.03125 times 6. Are there any questions on those? Because I think I'm just going to put the answers up here. Your question?
Well, no, I have a question. I'm going to try to plug it in as well, because I think when I was plugging mine in my calculator,
Uh-huh.
it just gave me the answer at the end when you kind of broke it up.
Yeah, you could, if as long as you're typing it in all correctly, I don't mind if you type it all in at one time. You just have to be careful and make sure you feel comfortable with your calculator, because if you mess any part of that up, it could all be wrong. Should be getting 48,237.45 here. Here I got 48,214.07. That's a little bit more of a difference on that one. This last one I'm getting 48,249.21. Anyone have a question on that?
So for me, it's just, I don't know how I'm doing that exponents on my calculator.
Oh, okay.
I can get it all the way to here, but then I don't know how to get this.
Okay, let me look at your calculator first to see if I can figure it out. So normally, let's see how 2 raised to 3 equals 8. Okay, so that's your raised button. See that X, Y thing?
Mm-hmm.
So let's do this. Do 1.02 or 0.02604. 6. Yeah, that's fine. That's good. And then now hit that X to Y button right there, raised, and then 72, and then equals 1.205. There you go.
Okay.
And then you have to multiply that times the 40,000. You all good with that? What about this last one? How long will it take to turn $3,000 into $4,000 at a 4.5% interest rate? Yep, so we're using this one. So 4,000 is A, equals 3,000 is P, right? And then E to the interest rate of 0.0425 times T. So replace that with 3,000, that with 4,000, that with our interest rate, and then T, leave it as T. And we're trying to get E by itself, so you first divide both sides by 3,000. That's your first step. Divide both sides by 3,000. And that'll give you 1 point, what is that? 33333, okay. And now you have to use your natural log button to figure out that natural log of 1.333 equals, and when you do natural log on this side, all that happens, and this is the critical key element of this whole thing, is that when you do the natural log on the right side, the only thing that comes out is this piece. The E is basically going to vanish from the right-hand side. So natural log of 1.333. So I get 0.287657 equals 0.0425 t. And I divide both sides by 0.0425. 6.77 approximately is t. And that would be years.
And then just to clarify,
Uh-huh.
down there, C, and what we just did, we use those two formulas because it doesn't say anything about monthly.
How often it's, yeah, that's right. Yep, that's right. So we are assuming simple interest here. We're assuming it's compounded continuously. And that's because, like I said, most banks and financial institutions do continuously because it is easier to calculate. And it gives you a bigger number, which would hurt the bank if you're giving them your money, but on that other end, the credit card people, they get more money, right? Okay. Y'all feel okay with this? All right. You still want me to put another rational function up there?
No.
No? You sure? No? You're okay? All right. In that case, we'll see you all on Wednesday. Go check your email. Like I said, I've got to get home to that file. And then once I get to that file, I will send it out. Yes. The quizzes that you're going to be turning in?